Okay, we were given a picture of raindrops on a piece of plastic. In some parts, if this represents a piece of plastic, okay, so some parts of the plastic were easier to see. The raindrops, they had a darker background and the raindrops are kind of illuminated. In other parts, they were a little harder to see. Let's see, here's actually, let's see if we can focus on that. Okay, yeah, I'm seeing that pretty clearly. So we see across here, especially, we can see the raindrops pretty clearly, and we can see that some are bigger and some are smaller, and they're pretty randomly distributed. So, there were actually two pictures. There was a picture, well, there are actually two pictures here. Okay. Now, the pictures are going to be posted on the document for the class, but the picture up here and there's a picture down here. The picture down here, I've got a tape measure running across the screen. Okay, in the picture up here, there's no tape measure. Now, the question is, are the raindrops down here the same as they are up here? Is this the same distribution of raindrops that this one was? That was the first question we wanted to ask. Because, let me give you the task. Our task is this. This represents 15 seconds that I held the plastic out in the rain, then I brought it in and photographed it. Once without the tape measure and once with the tape measure. Now, I did a series of photographs. I didn't always photograph the same one. I repeated this a couple of times. So the question is, are these two pictures of the same distribution of raindrops? Now, I asked people to, tell me what they thought, and I asked them to tell me why. And what most people said was, yeah, they look the same. Well, I'm not going to base public policy on that. Okay? I'm not going to base my corporate policy on they look the same. Although that was perfectly the answer that I probably would have given, and the answer that most people gave, and the answer that I kind of expected. A couple of people got a little more specific than that. So, then I sent people back to the drawing board and said, that doesn't tell me anything just because you think so. I mean, I trust you, you did a good class and you did real well in the last test. You appear to understand statistical distributions pretty well. I'm pretty well pleased with this class. So I have a lot of faith in your opinion, but you're going to have to give me details that I can verify. Okay? So, what do? Well, people had a little bit of trouble doing this. Some people had some pretty good ideas, and some people came up with what I would have considered a pretty valid reason for thinking that the two were the same. And then I just threw out this. Let's suppose that these are three raindrops that you see on the picture. And you see this configuration in both pictures. And this raindrop is square, and this raindrop is triangular, and this raindrop is kind of amoeba shaped, kind of amorphous. And not only do you see them, but you take some measurements and you find that these three distances are the same on both, give or take a little uncertain because you can't measure the distances exactly. The camera was a little closer one time than it was another time, so you can't really tell. But you could measure these three angles and see that they're the same. And you could even then look at the size of the drops versus the size of the triangle. If they're in the same proportion, you would determine that they're the same. And also, I don't know if anybody's ever seen a square raindrop. I sure haven't that I noticed, or a triangular one. And, I drive a lot, so, sometimes it's raining. I think if there was a rectangular raindrop in my field of vision, it might catch my attention because they all tend to be pretty circular. They actually aren't circles, but we'll see what they are. There's another picture that shows what they are. But if you saw this configuration with these angles on two different pictures, that would pretty much be airtight. You know, just seeing a square raindrop next to a triangular raindrop would convince me, and probably convince any court in the country if you were in a court case and had to prove something. Okay, well, that's one way you could do it. Okay, so I just make this, if you saw this in two different photos, you could be very sure that they were the same thing. Square raindrops and triangular raindrops are very rare. I actually don't even think they exist in this kind of situation. They shouldn't. You know, the surface tension pulls everything into a sphere and so forth. But anyhow, they're very rare. And to have them at the same spacing and same angles with the amoeba-shaped drop would be extremely improbable. Okay? And then somebody in class mentioned, yeah, something like the end of times. Well, I don't want to talk about the end of times, but also because, you know, I'll say, and very scary. Okay, so that's not something you would expect to see, ever, and it could freak you out. Okay, so my question then is, are there patterns in the first picture that occur as well in the second picture that are enough to convince you? So people looked around, people started seeing patterns. I showed this to one of our adjunct faculty who's done a lot of astronomy, and she said, yeah, reminds you of the constellations if you look at it the right way. Do you have the same constellations? It doesn't take many to convince you that, you know, it's very improbable that you'll ever see those constellations again on a piece of plastic like this, okay, under these circumstances. So, now I'm going to say then, people say, well, there are many patterns with many drops that appear to be repeated. And we could take measurements and see that all the distances and angles are consistent and everything. Differences are rare. And any differences that people might or might not have noticed might well be explained by differences in lighting and camera angle, because the two pictures aren't done quite at the same distance and quite from the same angle. So, you know, I list three things that might account for differences: lighting, camera angle, or of course, gremlins, thirsty gremlins that suck up water droplets when we're not looking. Okay, well, I don't know about the gremlins, but lighting and camera angle, okay. Okay, so this kind of is a way of answering the question, are these really the same picture? Are these the pictures, are both pictures of the same thing?